Okay, today we're going to do integration by substitution. This is our new tool for integration that will allow us to do a bunch more stuff. No proofs or anything, let's dive into it. I put this example up. We didn't need substitution for this. If you remember, this is in the form integral f dash x, f of x to the n dx. Yeah. And that we know that just goes to f x n plus 1 on n plus 1. So this question here would go to 4x cubed plus 1. A half plus 1 is 3 over 2. Divided by 3 over 2 is the same as times by 2 over 3. And that's our answer. We're done. Whoop. Plus c. Okay. We're going to do it by substitution. You will probably be given what to substitute in. But it's nice to know that you have to find it. I like to think of it as whichever part of the statement is trapped. Now, this bit that I circled here, that's trapped by the square root sign. And my language is a bit funny, but hopefully you'll see what I mean. If I let u equal to 4x cubed plus 1, then I know that du dx equals 12x squared. Ooh, you're sitting up front. Always going to be the case. Okay, bear with me. Now I want to rearrange this term here for dx. So I want to times that dx up and divide by all of that. I'll do it in two steps, okay? Du equals 12x squared dx. Dx equals du on 12x squared. Now, what I do is I substitute everyone in. This top term here will now become the integral of 12x squared square root of u, square root of u times dx. Now, I'm just going to use dx is that. Okay? So that's going to be du on 12x squared. What happens to the 12x squareds? Well, they magically disappear. Wowzers. Okay, keep your eye out for that. A lot of the time the derivative will be sitting at the front. Just the way it has to work for these. Integral of u to the half du equals u to the 3 over 2, 2 over 3. Substitute back in for u. So this guy here, where was u? U's bomb all the way up there equals 2 over 3 4x cubed plus 1 to the 3 over 2 plus c, which, lo and behold, is the same as what we have here. Okay. Okie dokie. So now I'm going to do an example, another quite simple example. You can see that derivative kind of sitting out the front, okay? So we might not need substitution, but we're going to do it, and we're going to use the bounds. Okay, this one is a definite integral, and it's got bounds. I'm going to show you a couple of ways to do it, and just how, in fact, why we do something that we do. Okay, my first thought is, who's trapped? It's this guy, x cubed plus 1. U equals x cubed plus 1. Du dx equals 3x squared. Rearrange for dx. Whoa, I forgot my dx up there. Whoopsie daisy. Okay, there we go. Rearrange for dx. Dx equals du on 3x squared. Okay, this guy here is now going to become the integral from 2 to 0 of x squared, x cubed plus 1 is u, so that's root u times du dx, which is du on 3x squared. So what I've done is I've put that u in there and that guy in there. Now these bounds, the point of doing these bounds kind of don't mean anything at this point. Look, I've got x's and u's. These are, in the initial question, they say when x equals 2, from x equals 0 to x equals 2. Am I talking about u's or x's here? Well, let's just get rid of them, okay? For now, just bear with me. There we go, and I've got that. Okay, these x's are going to cancel. So that equals the integral of u to the half du. Now, what are my bounds? Well, my bounds I have to figure out because I'm talking in terms of u now. So what I can say is, well, when x was 3, what was u equal to? That was 3, oh, when x is 2, sorry. When x is 2, u is equal to 2 cubed is 8, plus 1 is 9. And when u is equal to 0, when x is equal to 0, u is equal to 1. So my new bounds, instead of 2 and 0, are 9 and 1. Now I can just go ahead and do it, okay? And I'm going to get u to the 3 over 2 divided by 3 over 2 is times by 2 over 3. And I'm going from 1 to 9. Subbing those in, I get 2 over 3. I'm just going to rip that guy out the front there. 9 to the 3 over 2 minus 1 to the 3 over 2, which is, what's that? 2 over 3. The square root of 9 is 3. 3 cubed is 27. Minus 1 is 26. 26, which is 52. 52 on 3. Okay, good. The other way I'm talking about doing it is it's the same thing, okay? Remember I said these bounds here were a little, that they're talking about u. Okay, what I'm just gonna come out here, I'm gonna do this bounds on u to the 3 over 2 divided by 3 over 2, which is times by 2 over 3. And I'm going from somewhere to somewhere. Alright, that should be the u's, but we don't have them right now. So now I'm just going to switch back to my x's. Well, I know that u is x cubed plus 1, so I get 2 over 3 x cubed plus 1 to the 3 over 2. And now, because I'm in terms of x, I can use those x bounds. Okay, so I can leave that original 2 and that original 0. Now I can sub in those values, and I will get, I'll take that 2 over 3 out, and I get 2 cubed, which is 9 to the 3 over 2, minus 1 to the 3 over 2, which is the same. Okay, so you should really, if you are integrating with respect to u, you should change your bounds here. You'll see this in some trig questions, which I might show later. Actually, if you want to practice one, I'll just write this over here, and you can go ahead and practice. Integral pi on 6 from 0 cos 4x by sine x dx. Now you don't need substitution, remember, because we've got that derivative guy going on. But just for the purpose of this, I'm going to say u equals the trapped guy, which is cos x, because that is the same as cos x. The 4 is kind of trapped by that power. in the magical world. He's trapped. Free him. Alright, now this is where we need to use substitution. Okay, it's not looking like before. There's no, that derivative is not sitting on the outside. Okay, so I'm going to need substitution here. This is the real purpose of it, okay? Again, just do it the way we always have. U, the trapped guy, is x plus 1. Yep, and I've got no bounds on here, okay? They're a pain. Do those in practice. U equals x plus 1. Du dx equals 1. Well, that's easy. So that means du equals dx. Now I can substitute in, and I get this guy comes down, and it becomes, well, the integral of x times the square root of u, and then du becomes dx. Dx becomes du. Yes, much better. Right. This x is here. Remember in these other examples, what happened? They cancelled. Magic. That cancelled. Up here. Oh my god, it cancelled. It always cancelled. But in this one, it's not going to cancel. Easy. What I can do, I want to get rid of that x in terms of u. What do I know about, do I know any relationships between u and x? I sure do. Just there. So if I know that u equals x plus 1, I also know that x equals u minus 1. So I can plonk that in here. So this is another substitution, I guess you could say. Equals square root of just u minus 1, root u du, and I'm good. We'll have to do it. Brackets there to be neat. Equals integral of u to the 3 over 2 minus u to the half du. Then we've just got powers. U to the 5 over 2 divided by 5 over 2. 2 over 5 minus u to the 3 on 2. 2 over 3 plus c. Okay, this is a good example because this is when substitution is needed. When after you do your substitution, you're still left with some guy here. Now you should be able to rearrange to get rid of it. Okay, one more example. This is a cracker. Okay, I'm pumped. Okay, this here I do not know how to integrate yet. Okay, I'm going to tell, before we do this, I'm going to do this graphically. What the heck is that? 36 minus x squared, just the positive square root. Well, hold on, that's a semicircle. Radius 6. Whoa. 6 minus 6. Terrible circle, don't do that. I only want from 0 to 6. It's a quarter of a circle. Far out. So the quarter of a circle is a quarter times pi times the radius squared, which equals 36 pi on 4, which equals to 9 pi. Done. Okay, good. But I want to be able to do this using substitution. Okay, what am I going to substitute in? Bit not that intuitive. Okay, guys, I'm going to tell you, but I want you to kind of remember this. I'm going to use the substitution x equals 6 sine u. Alright? Now that's a little bit funny, but let's work with it and see what happens. If I know that x equals 6 sine u, then dx du is equal to, sine goes to cos, right? Okay, 6 cos u. Rearranging for dx, as we've done in the past, dx equals 6 cos u du. Alright, now I'm going to take this guy, this bad boy, and put him here, and then I'm going to take this guy and put him here, and then this integral, whatever, is going to become this guy will become the integral of the square root of 36 minus x squared is 36 sine squared u. Yep. And then that dx is 6 cos u du. Now I've got my bounds to contend with here. So what I'm going to do is my little bounds here. Well, I'm going to say when x equals 6, when x equals 6, 1 equals 6 equals 6 sine u equals 1, u equals pi on 2. Okay, good with that. Don't that bit there. So I'm going to put a pi on 2 as my upper bound. On the lower bound, I'm going to say when x equals 0, 0 equals 6 sine u equals 0, u equals 0. Okay, so that 0 is still there. So I've changed my bounds to suit u. Could leave them for the x's, but as I said before, it's a little bit dodgy. That's the integral of pi on 2, 0. That's, I'm going to take 36, I'm going to take that 6 out, I think. Can I do that? Yep. I'm going to take the 6 out from here, and the 6 out from here, and I'm left with a 36. That's because of this 6 and this 6 is 36. Here I'm left with 1 minus sine squared u, and then I've still got a cos u du. Alright, equals 36 integral pi on 2. 1 minus sine squared is cos squared. The square root of cos squared is cos. That cos u is still there. I'm running out of room here, so let's just go up here, okay. Equals 36 integral pi on 2 to 0 of cos squared u du. How do I integrate cos squared u? Well, that was in the last video, so I mean, look back if you need to, but the integral of cos squared u, I'll do it here. Well, he changes to a half plus a half cos to u. Sorry, u, not x. Remember that from last time? That was handy. To u equals 36 integral pi on 2 to u on 2 plus a quarter sine to u. And sorry, I've integrated here, so I get this happening with my bounds pi on 2 to 0. Now hopefully we can squeeze this in here, okay? Let's go 36, chuck the pi on 2 in, and you get pi on 2 divided by 2, which is pi on 4, plus a quarter sine 2 times pi on 2 is just pi, and then I get minus 0. The sine of 0 is 0. Okay. That sine of pi, what's sine of pi? Sine of pi is 0. So that equals 36 pi on 4, which is equal to 9 pi. the same as up there. So that's a really nice one. Okay, guys. Integration by substitution. Thank you.